Hi Emma, this is the problem that you asked me to do. So I want to try work through it reasonably quickly and see how you go in following. Okay, so the first thing we need to do is to express the area of this shape here in terms of x and y. So naturally, what I've done, I've created two areas. So there's area 1 and there's area 2. So they're both rectangles, so that one there will be 8y, and that one there will be x times y minus x, because that's y and that's x, so therefore that's y minus x. So if I expand that out, I get the expression 8y plus xy minus x squared. Then it asks me to find a perimeter in terms of x and y. So naturally perimeter is all the length of the outside bit, so adding up all these guys here. So if we do that, we come up with the following expression. So P equals y plus 8 plus x plus x plus y minus x plus 8, which simplified leads me to 2y plus 2x plus 16. Then in the question it says, if the perimeter is 64 centimetres, so that's I've made this replacement here. And then if I simplify down, if I divide everything by 2, I get y plus x plus 8 equals 32. And in simplest form, I guess it's 24 equals x plus y. So what that also means is, if I look at my diagram here, that there is y minus x, and if I get y equals to 24 minus x by rearranging this guy here, it allows me to do part 2 here, which is find the allowable values of x. So what I've done here is I've said, well, y is 24 minus x, and then I'm using this expression here, and I've substituted y with 24 minus x. So naturally, I need this whole y minus x bit to be bigger than 0 for me to even have a rectangle, or to have this baseline here. So that's got to be bigger than 0. So I've made the substitution and then solve for x. So I've got 24 minus x is less than 0. If I solve that down, I get x is less than 12. So what that means is my allowable values for x has to be bigger than 0 for anything to exist, and it can only go as high up as 12, but not including 12, for me to have this shape possible. So that's I reckon that's probably the most challenging part of the question, is thinking about your allowable values of x. Okay, as I scroll down, we're going to lose the picture there, but hopefully you can sort of still follow through. So then it asked me to find the area in terms of x. So again, I've just subbed in 24 minus x for y, and I've expanded and simplified, and I've solved down again. So once I do that, I come up with this equation here, which when I factorize out, gives me this. And then in order to draw it, because we're interested in the maximum, the easiest way for us to do that is to complete the square. So I factorize out my negative 2, I complete the square by halving the negative 8, and I'm going to subtract 4 squared, which is 16. So negative 16, take a 16, even though I haven't written it in there, will give me negative 112. And then when I expand out to get into turning point form, you can now see that my turning point is 4 and 224. So if I try to draw that, what I've actually got here is my area along the y-axis, and x is obviously the values of x on the x-axis, and my maximum area, which is 224, will occur at the turning point when x equals 4. So at the value of x equals 4, my area peaks at 224. So in terms of drawing the graph, and this is where the allowable values of x come in, which is really what your domain is, we've said x can't be 0, so therefore that's an open circle. So my y-intercept is 192. And then at 12, I can't go further than 12, so that's why I have an open circle of 12. So if I sub in the value of 12 into area, it gives me 96. So there you pretty much have the whole question. So a lot of algebra involved, but you need to think about what it means to actually maximise your area, and also a little bit of simultaneous equations involved. So hopefully that helps solve your problem, because the analysis question is very, very much like this. So have a sort of view of that. Hopefully that makes some sense. And even if you need to watch it a couple of times, then do what you got to do. If you need any more help, just send me an email. Thanks. Bye.